Section 12.1 is called tangent line. We're going to look at something called a tangent line. A tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. The point where a circle and a tangent line intersects is the point of tangency. So here's a picture. This is the tangent line in blue. It touches the circle in only one point, and that point is called the point of tangency. So it doesn't look, well, it touches in exactly one point. It's really hard to draw a clean circle and line, but the point is that the tangent line does not pass through and go through 2 points. That would not be a tangent line. A tangent line touches at 1 point. So it comes along, barely touches, and keeps going past. So 1 point of tangency for every tangent line. So here's our first theorem. It says if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So here's a picture. If line AB is tangent to the circle O at point A, then line AB is perpendicular to the radius OA. So what that does for us is it gives us a reference for finding different lengths or angle measures if we know that this is a right angle at the point of tangency. So we can use that information to try and find missing angle measures. So I want to find angle L, angle LMO, and angle LPO. O is the center of my circle, LM is tangent, LP is tangent, so I know automatically that these two are right angles. So without doing any computation, any tangent line is perpendicular to the radius at the point of tangency. What do you remember about the angles of a quadrilateral? Because I've got a 4-sided figure here. Hopefully, remember that all these angles have to add up to 360. So I've got 90 plus 165 plus 90 plus angle L should equal 360. If I add these all up, I get 345 plus angle L equals 360. Subtracting from both sides, I get 15 degrees for angle L. So that's one way we can use tangent lines to find some missing pieces of a diagram. Theorem 12.2 is the converse. Remember we had a theorem and then the one that was said in the opposite is the converse. So this time we say if a line is perpendicular to a radius, then the line is tangent. Our first one said if we have a tangent line, then it is perpendicular. This says if I am told that two lines are perpendicular, then I know that the line that is not the radius is a line of tangency. So in other words, if AB is perpendicular to OA, then AB is tangent. And we can use that information in the same way we did theorem 12.1. We'll do a few more of those in class. Right now, let's look at this. Find the radius if AB is tangent to the circle. So AB is tangent. My radius is OB, or my unknown x. Because of that, I know this is a right angle, and I can use my Pythagorean theorem. So 15 squared plus x squared equals 17 squared. 225 plus x squared equals 289. Subtracting, we find that x equals 8. So another way to use a tangent line and a radius to find values in a diagram. So we have one more theorem, theorem 12.3, and it says if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So in our diagram, let's find it, if CA and CB are both tangent to circle O. Sorry, this is almost going off the edge. Then CA is congruent to CB. And you can see in the diagram that we have our right angles because of our tangent lines and our radiuses. Radiuses always equal each other. And we now know that these tangent segments are also congruent. So let's see how that's going to work for us. So here's another diagram. Here's my point outside the circle. Both of these are tangent lines. I don't need to draw the radius and the perpendicular, but it doesn't hurt. However, I do know that 2x plus 10 has to equal 3x plus 7. So subtracting 2x from both sides and subtracting 7, x equals 3, and that's my missing value. So we've done 3 types of problems. The 2 key pieces of information are that a tangent line is always perpendicular to the radius, and if I have 2 tangent lines that join at the same point outside the circle, those 2 segments are equal.